Welcome to the Explainer. Okay, I am absolutely thrilled to have you here today because we are looking at one of the most exciting leaps in artificial intelligence right now. We are moving from basic single pass RAG, retrieval augmented generation, into the absolute frontier of autonomous investigation. If you've been following AI at all lately, you know things are moving fast. But this shift, it completely changes how machines process and synthesize knowledge. So let's start with a reality check. You know that incredibly frustrating moment when you ask a standard AI retrieval system to synthesize a really complex comparative report? Maybe you ask it to compare different approaches to a technical problem, cross-checking all the claims. What actually happens? It usually collapses spectacularly. It spits out this shallow, generic answer that barely scratches the surface. Why does that happen? Okay, let's dive into this. Here is our roadmap for today. We'll start with the limits of standard ROG, then enter deep research agents, cover the 5 core design patterns, look at some open source agent architectures, and finally, talk about surviving production realities. All right, part 1, the limits of standard RAG and why single pass retrieval just outright fails at complex tasks. Think of standard RAG like a slightly lazy student. They read the very first Google result, grab a couple of bullet points, and call it a day. Standard RAG operates in seconds, pulling maybe 5 to 10 chunks of text from a single query. Now, that is fantastic for trivia, but it's entirely useless when you actually need to cross-check claims. A single search is just completely blind to the nuance, context, and contradictions you find in real-world information. By stark contrast, look at a deep research agent. It runs from minutes, pulling from 20 to over 100 sources, and uses iterative queries to relentlessly dig deeper until it has the whole picture. Which brings us to part 2. Enter deep research agents and this massive shift toward autonomous investigation. So, what exactly are these systems? Deep research agents are essentially systems that extend the standard REACT, or reason and act loop. They don't just blindly fetch data. They plan out an entire investigation, they iteratively search, reflect on what they found, triangulate their sources to make sure the data is accurate, and finally compile a truly comprehensive report. The main takeaway here is that they are designed to produce a fully structured deliverable, complete with real citations, rather than just spitting out a quick paragraph. They are built for those open-ended scopes where accuracy matters way more than speed. Moving right along to part 3, the 5 core design patterns. You can think of these as the superpowers of deep research. Let's see how this builds. At the heart of this methodology is a highly cyclical loop. It always starts with a plan, moves into search, loops over to reflect, and only when it's fully satisfied does it move to write. Instead of one straight line, it's a constant evaluating cycle. The AI is literally asking itself, wait, do I actually have enough information to move forward here? It fundamentally mimics how a human researcher would tackle a topic. And what's really interesting about this slide is how these 5 interlocking patterns stack up. You've got iterative retrieval loops, web search integration, self-reflection, source triangulation, and report generation. The magic here is that later queries are continually informed by earlier results. So if an agent's first search uncovers a new, highly specific term, it immediately spins up a targeted follow-up query about that exact term. A basic broad initial query never would have found that in a million years. Let's do a quick so what check on the reflection loop specifically. Search, evaluate, decide, and then either search again or proceed. Why is this so vital? Well, reflection prevents premature report generation. By evaluating what it has actually found, the agent actively identifies exactly what evidence is missing. It deliberately pauses to say, actually, scratch that. I don't have enough data to back this claim up yet. I need to search again. This is your ultimate safeguard against half-baked AI answers. All right, part 4, open source agent architectures. Let's step into the workshop and see how people are actually building these. When you compare the big open source architectures out there right now, you see some distinct strategies. Take GPT Researcher. It uses a plan and execute architecture, relying on parallel crawlers to scrape over 20 sources per task. It casts an incredibly wide, concurrent net to gather diverse information fast. LangChain takes a totally different route. It uses a supervisor that delegates parallel searches to subagents, so it's basically acting like a manager directing a team of junior researchers. Meanwhile, Llama Index uses a workflow-based agent combining local document indices with live web searches. That is perfect for when you need to cross-reference your own internal private data against the massive public internet. Then you have Stanford's STORM architecture, which takes a wildly creative approach. It discovers perspectives, simulates interviews, curates an outline, and writes an article. It literally simulates conversations between different expert personas. Imagine a simulated scientist asking probing questions to a simulated economist, both grounded in real web sources. By doing this, STORM creates Wikipedia-style articles that evaluators actually rated as 25% more organized and broader than standard ARG outputs. That is just so cool. But the crucial point here is managing all that data, which brings us to sub-agent context isolation. When you've got multiple agents researching different subtopics, you absolutely must give each subtopic its own separate context window. It prevents cross-contamination. You want to keep those parallel research tracks cleanly separated so the sub-agents don't get confused by unrelated data. You only bring the whole shebang together at the very end for a single-pass write-up. Finally, Part 5, Surviving Production Realities. Let's talk about the boss fight of deploying these: cost, latency, and quality control. Deep research is insanely token-intensive. Just writing the final report alone can eat up 10 to 20,000 tokens. When you add up brief generation, sub-agent research, multiple rounds of reflection, and the final writing step, a single complex task can burn through up to 200,000 tokens. That sounds absolutely massive, right? It feels like the kind of operation that's going to completely drain your wallet if you run it at scale. But check out this surprising punchline. Even at 200,000 tokens, a massive, comprehensive research task only costs between 15 and 50 cents in actual dollars. Literally under $1. It is astonishingly cheap for the level of high-quality, synthesized knowledge you are getting back. Of course, you still want to optimize. To keep things lean, use cheaper models like GPT-4o Mini for the messy, iterative steps, the searching and the reflecting. Save the big guns like GPT-4o strictly for that final report generation. Also, a few pro tips. Always compress your findings to strip out raw HTML. Cache your search API results so you aren't paying for redundant calls, and for sure set strict token budgets so an agent doesn't just spin its wheels infinitely. Okay, let's fire through some common pitfalls in a fast-paced cheat sheet. Pitfall 1, context window overflow. Your agent crashes because it read too much. The fix? Compress those findings and isolate your subagents. Pitfall 2, search query repetition. The agent is just banging its head against the wall, searching the exact same phrase over and over. The fix? Track the search history and strictly enforce query diversity in your prompts. Keeping the momentum high. What happens when you hit infinite research loops? The agent just never feels satisfied. You fix this by hard setting maximum iterations and using concrete coverage scoring thresholds. What about source bias, where the report leans way too heavily on one single viewpoint? You explicitly prompt the agent to seek out multiple perspectives and programmatically verify the diversity of its sources. And then we have the dreaded citation hallucination. The agent just totally makes up a fake URL. The fix here is to pass a strict numbered source list to the report writer and programmatically validate those links after generation. Finally, if you're getting hit with a token cost explosion, budget per sub-agent and drastically compress the raw web content before feeding it back into the loop. All of this incredible engineering really just points back to a core philosophy of deep research, summed up perfectly right here. Never trust a single source for important claims. Source triangulation catches misinformation. By adopting human-like source verification, these AI systems are finally doing real, reliable investigative work. Which leaves us with a truly fascinating thought to end our explainer on today. If autonomous AI can now iteratively search, reflect, triangulate sources, and synthesize these incredibly complex reports, what exactly defines the future of human research? Where do we fit in? It's an amazing question to ponder as you start experimenting with these deep research agents yourself. Thank you so much for joining me today, and keep exploring.